And what we're going to do is go through the introduction and talk about what's covered in the class. But before I start the class, just let me give you some information about myself and Leroy Parker. I'm a forensic consultant and instructor now with Parker Forensic Services. I retired from FDLE as a crime analyst supervisor, and below is my home address and my email address if you need to get hold of me. What I normally like to cover is the first part, knowledge is power, so you got to empower yourself. Knowledge is not good unless it's shared, and we're going to try to share as much knowledge as possible in this 40-hour presentation. I would like each student to please note that you ask a question because you want to know the answer. There's no question that's a dumb question, and I'll answer the question to the best of my ability. And I'd like everybody to actively participate in the workshop. Okay. This is just introductory to break the ice. I'm saying that everything you learn in kindergarten. And this is actually what's going to be covered in the workshop. You have individual drops of blood that fell because of the force of gravity. The speed is less than 25 feet per second, and that's why they fall into low velocity. Also, then we get into multiple drops of blood, and that would include cast-off blood stain from a weapon, low velocity less than 25 feet per second, splash blood, which is also velocity, somebody's bleeding and dropping blood, satellite spatter, as the blood drops, you have satellite created as the blood gets rid of its energy, and you have arterial bleeding. If somebody has a punctured artery, as the heart pumps, then the blood comes out. And then we get into impact blood spatter, which means the blood is sitting there and a force is applied to the blood. We have several categories. We have medium velocity, 25 to 100 feet per second. High velocity in greater than 100 feet per second. And then we have other types of patterns, which would include contact blood stains, imprint. An imprint is a contact stain with identifiable details, wipe and swipe blood stains or smeared blood stains. And then we have expirated blood. Somebody is breathing and still getting blood out the mouth or the nostril. Okay, in blood stain pattern analysis, we normally refer to what is known as the target. And the target is any place where blood is deposited. So it could be any place in the crime scene where blood is deposited. And all targets are not suitable for reconstruction because some of them absorb the blood and the blood lose the circular or the oval shape that is required to do the width to length ratio to determine the impact angle. That is the angle at which that blood stain hit the surface. There are any significant differences between preserved blood and fresh blood. And I put this in because when we teach the classes, we use blood that we get from the blood bank or from an animal. We have to put the preservative in it, and that has to be compared with blood coming from the body, which is fresh blood. And then the other thing we do, we have to keep the blood at refrigerated temperature. When we get ready to use it, we get it at room temperature, which is different to body temperature. And initially, we did some research, and there's no significant difference between blood that is fresh and blood that's preserved and blood at these different temperatures. So just to get past that. Okay, to get into drop blood, effect of delivery mechanism, the area of the body from where the blood fell, and that we're going to set up that in terms of some experiments to determine the effect of the delivery mechanism and the volume. Effective delivery mechanism, that is the area from which the blood fell, on the diameter. So we're going to compare the blood with the diameter formed from each blood spot. And then effect of the height fallen on the diameter of the blood stain. So as the height increases, so does the diameter. And the effect of the surface, the target surface on which the blood fell. And each target is different. So some are smooth, some are hard, some are soft, and some are absorbent. So they have different patterns. And the effect of angular stains And the angular stains are what's going to be important in doing a blood stain pattern analysis reconstruction. Now, what is drop blood? And where is drop blood normally found? Drop blood is found where anybody in an upright position is standing and dropping blood to the surface. So the blood on the target is the drop blood that's coming or falling because of the force of gravity. Can the volume of drop blood vary? The volume of drop blood varies, and as you'll see in some of the assignment, it varies from about 0.45 milliliters to about 0.80, in some cases 0.90. So it depends on the surface on which it's falling. But these are all outlined or determined in the assignments that you'll go through when you do the assignment. Is the diameter of a drop of blood related to its volume? That's correct. The larger the volume, the larger the diameter, assuming that all things are constant, that the height is constant and the drop-in surface is constant. Is the diameter of a drop of blood also related to the height from which it fell? That's correct. The higher the height, the larger the diameter of the drop of blood. Is the blood spatter pattern influenced by the surface from the height? That's also important because as the blood falls from a higher height, the speed at which it's falling increases because of the force of gravity. So the impact would result in a bigger diameter, but it would also result in a more spine-shaped diameter. And is the spatter pattern of a drop blood influence on the surface? Again, that's very important. If it's a smooth surface, you get a nice round spot. If it's a rough or observant surface, then you can get a nondescript shape, as in a carpet or a piece of wood or a piece of cardboard. What is meant by the terminal velocity of a drop of blood? The terminal velocity is the maximum speed a drop of blood reaches in its flight. So the terminal velocity means that the blood is falling, it gets to this maximum speed, and it maintains that speed for the rest of its fall. What is the terminal velocity of a drop of blood? Again, we can determine that. The terminal velocity is usually about 25 feet per second, but we don't usually get involved in that unless somebody wants to get into that. But the terminal velocity is usually about 25 feet per second. Calculations, if necessary, and the calculation, the distance the drop of blood has to fall to reach terminal velocity, the distance the drop of blood has to fall to reach any given speed, and the final velocity of a drop of blood for any distance. And the basic formula with some alteration is that V squared equal U squared plus 2Fs. V is the final velocity, U is the initial velocity, 2F stands for acceleration due to gravity, and S in this case is for the distance the blood stain traveled. So again, V, the final velocity, U, the initial velocity, F, the acceleration due to gravity, and S, the distance fall. It's the degree of circular distortion of a drop of blood, that's the width-length ratio proportional to the angle at which it fell, or it impacted the surface. That's true. And we can do that in assignment where you can determine that there's a change in angle, so does the shape of the blood. It gets more oval the smaller the angle. Is there several ways to determine the length to width ratio? Which is the best and scientific way to measure the blood spot? There's an assignment in the back book which we'll go over as we go along with the class. How are your impact angles affected by your measurement, especially the length? And that's very significant. How important it is to correctly measure the width and the length. It's absolutely important because we're using very, very small measurements which are measured in millimeters. So a half a millimeter could make a big difference relative to the 1 millimeter or 2 millimeters. In which units are the width, in what units are the width and diameter of the blood stain, and they're all measured in millimeters. In blood stain pattern analysis, what is meant by the impact angle? And the impact angle is the angle at which a drop of blood impacts a target. And that could be determined by dividing the width by the length and doing the second function sign, or looking up the decimal in the tables to get the angle. How much mathematics is involved in blood stain? Again, it's very little, and we usually have a math review before we get into the understanding the math involved in it. The math review would include angles, complementary and supplementary angles. Complementary angles mean they add up to 90 degrees. Supplementary mean the angles add up to 180 degrees. Triangles, and the properties of right angle triangles, because we're going to be concentrating in this case on right angle triangles. So everything is based on right angle triangles. And the trigonometric ratios, which are the sine, cosine, tangent. And this is just a slide just to give you some information. In the island I was born, St. Nevis, our motto is Principia non homines, and this means, translated in English, principles not men. And so before we do the math review, I want to make sure you understand principles and not learn how to solve a problem, but you apply math principles to the solving of the problem. So math review, we do the math principles, how to work with simple equations, and making what you want to find the subject of the equation. Example, the tangent of the impact angle equal the opposite side over the adjacent side, or the opposite side equal the adjacent side multiplied by the tangent of the angle. Why is the sign abbreviated? Sine ratio, or that? That's to determine the impact angle. To determine the impact angle, we always use the sine ratio, and to determine the point or area of convergence, we'll use the tangent ratio, which we'll see later. So can the cosine or the tangent be used in blood stains? Yes, we use the sine and the tangent, but at no time at all, for what we may be doing, we will need to use the cosine ratio. Answer to the questions about how much math would be necessary in blood stain. And we need a sine formula to use to determine the impact angle. And we use the tangent to determine the point or area of origin of a blood spot. Can the length to width ratio be used? Yes, most people use the width to length ratio. Divide the width by the length, get a decimal, hit the second function sign, or which is the arc sign, or they can go to the tables, or they can go to a perfect sine graph. But in some cases, you can use the length divided by the width. In this case, you always have to go back to a graph that you previously created. So if you made a mistake in creating that graph, then you perpetuate the mistake by using the graph, which was an error before you started. And to answer the question again, this is how we determine the area of the point of origin. And my philosophy, don't sweat the small stuff at work. As a result of understanding the simple math, you should no longer have any problems in your future blood stain pattern analysis reconstruction of impact spatter. Can any morphological characteristics of blood stain determine the effect of horizontal motion? And what this is actually saying, if you're walking faster, as the blood impacts the surface, you get a smaller angle. If you're moving slow, then as the blood impacts the floor or the surface on which it's falling, you get a greater angle. So the shape of the blood is affected by the rate or the speed by which the person is moving across the surface. How does one determine the direction of travel of a horizontal blood spot? How does the faster motion influence the impact angle? And how does the height of the moving normally drop and produce when on the horizontal target? And then we get into multiple drops of blood. Now we move away from single drops, and that would include cast-off blood stains, arterial bleeding, which is a form of projected blood. It has an initial velocity. Implant burst pattern, which is beating, stabbing, gunshot, or machinery, industrial, and this is normally getting into medium and high velocity. And then we have splash blood, which is free-falling blood in excess of 1 drop, and this is back to low velocity. And then we have the satellite spatter, which are streaks, round or oval, and these are created as blood falls upon itself, and the blood gets rid of its energy, and so it bounces up and creates circular spots, small spots, which we call satellite spatter. In blood stain pattern analysis, we determine the point or area of convergence and the point or area of origin. The point or area of convergence is normally done on the surface where the blood stain is, and we just draw lines in the opposite direction to the tail of the blood stain of the selected spot, and where these lines converge is the area or point of convergence. The point or area of origin is three-dimensional, so we have to know the impact angle, which is determined by dividing the width of the blood stain by the length, and multiply that impact angle by the distance from the point of convergence to that spot. And that's also explained in the assignment as we get into the assignment later. What is cast-off blood stain? What is significant about cast-off blood stain? And what are the cast-off blood stain patterns normally found? Cast-off blood stain is blood which is created from a moving object as a result of a change in speed and or direction. It's significant because they occur in a linear pattern where the stains or the angle of the impact angle of the spots gets smaller and smaller, and cast-off stain are normally found on the ceiling or on any surface where the object is swung and blood is cast off as a result of a change in speed and or direction. What information can be derived from cast-off blood stain? You can determine the handedness, the number of blows. These are some of the information that can be determined from that. Can the point of convergence and the point of origin be determined from some cast-off blood stain? Yes, it can be done for some cast-off blood stains. We have to establish the 90-degree stains, and then we can pick some of the smaller or the oval shape, and then we can get a right-angled triangle and get a relative distance from where the blood was cast off, or the nearest point from where the blood was cast off to the target surface. Arterial bleeding, which is a form of projected blood because it has an initial velocity. And what's significant about arterial blood stain is that it's coming from some artery in the body that is punctured, and it allows the blood to come out as the heart pumps. What arterial blood stain pattern normally found? And again, that's normally found on the wall, any surface in the blood stain, like a horizontal surface or vertical surface, depending on where the victim was when he or she received the arterial puncture to cause the arterial bleeding. What information can be derived from arterial bleeding? The location of the victim, the movement of the victim. Can the point or area of convergence of arterial bleeding be determined? It depends on what kind of stain. You can get a relative height, but you cannot do an exact distance because, again, the blood stains are coming out, and they're affected by the force of gravity, so they're falling they're actually going downward. So it's you can get a relative height, but you cannot get the exact location.